final section will concern itself with integration of project management with the Git source control. So if I explain it again, Git is simply a source control, and to have any project management associated with Git, it is a slightly different process. You may need a different tool. And the tool that we are going to use today to illustrate this concept of project management is going to be Telerik Team Pulse. And the illustration on the right-hand side of your screen really shows why using a project management tool with Git source control is extremely desirable. You see developers at the top making various commits, and the project manager at the bottom, who's not only looking at commits while he's concerned about source code, he's more concerned about what is the status of various work items and how much time it has taken to complete that task. So this bridging between source control and project management system is what is available in Team Pulse, and we'll take a look at that at the end. Okay, so next on we have the basic Git. So the first question is, what is Git? And there was already actually a question that was put forth by people saying, what is Git source control? All right. So I've explained in the introduction that Git source control is nothing but a simple source control version system, and the specific nature of this version control system is a distributed version control system. So what do we mean by distributed, and basically why should you be looking at the version control, this version control system? So just to bring an analogy, many of you may be familiar with it from the past, is other source controls. And other source controls that you may be familiar with include VSS or the more recent TFS source control. You may be familiar with maybe Subversion. You may be familiar with Perforce, or you may, and there have been actually a lot of them around. So the Git is a special kind of source control system called a distributed version control system. So why do you really need to use Git, or why are people preferring Git these days? So the first reason why people want to use Git is because it is open source, ergo free. So people kind of can lower their ROI on their deployments in the enterprise. Second, and most importantly, it's the speed at which this source control works. Now, speed also is available because of the simplicity of the source control that is there. Now, because of speed and simplicity, the hardware that is required to run the Git source control is really very low. If you have used TFS in the past, you know it comes with huge hardware requirements, or other enterprise systems come with huge enterprise requirements. Here Git really can start with very low-end hardware as well. So that's been one of the primary reasons. The other reason is about it works offline. When I say offline, it means that you can actually take all your work and continue to work on the version control system, and then when you actually sync it to the central repository, all the version changes that you have done in the source control are also reflected in the central repository. It's just not one granular check-in. In very, very simple words, if I have to tell you the difference between a normal version control system versus Git source control system, I would encourage you to think of Git as a local versioning system for all your files. It's a good start at that point. Think of it simply as something in your file system that is going to maintain versions of all the files in your computer, or of a specific area in the computer, let's say a specific folder. So as we begin our journey into the Git world, that is the first thing that you should keep in mind. Think of it as simply a place where, or a system that basically allows you to maintain versions of files that may be located in one folder. So let's say I'm starting to work with Notepad and I include a few lines. I would like to check that in. Then I can change the version, or then I can edit the file, add more information, again check that in. So now we have two versions of the file. So think of Git as that system that helps you maintain different versions of files in your local file system. We'll grow this understanding as we go forth. Git version control system really works on snapshot storage. So for those of you who are familiar with other source control systems, you would know that they're also incremental in nature. What snapshot means that for maintaining a version, Git does not maintain increments. Git actually maintains full snapshots of files that may exist at a particular time. So if you have 3 files and you say to Git that I want this snapshot to be available or this version to be committed, Git goes ahead and creates a snapshot of the 3 files at that particular time, and so on and so forth, and it moves forward. In Git, you get all or nothing updates, which means you put everything in, or and it just gets, everything just gets on. You can't actually choose to say, in this file I only want this particular increment to go in. So please remember that. And also there are no partial checkouts. You are essentially going to be checking out everything as you go forth working in Git. Now to install Git and configure it, and I also see a question about on what all systems what all systems can Git be installed on. So Git is available for Windows, for Linux, for Mac OS. So you're pretty much covered on all platforms. So it can be installed on everything. The installation and configuration on Windows is what we will be covering in this session today. I've put down 2 links there, and the most preferred download version is called MySysGit. It's one of the, I would say, implementations or the simple builds that are available out there for the Git source control, and installing it is as simple as downloading the MSI file and running it on the system. And this MSI actually goes ahead and installs a few things. So I'm not going to do installation in front of you, which is pretty simple. You can actually just run the MSI file yourself on Windows and get about working or start working with it. What you will need to do after you have installed it is do a little configuration, and configuration is nothing but specifying your username and email so that Git, as it is working through with you, can associate the user with each of the commits that are going to come in. Now, some of the Git tools that you will get with the installation include the Git GUI. This is basically the main shell in which you will be working. It's a GUI shell. So since since we have a lot of people, I would simply start who are maybe beginners. So I'm going to start with the Git GUI itself, which is a GUI interface. Makes understanding and working with Git much simple. GitK is a visualization tool for visualizing the branches that the Git has in the local repository or in the repository. So we'll take a look at GitK as well. And kdiff3 is simply a merge tool, a 3-way merge tool really, that helps you merge conflicts. So if these words are sounding difficult at this time, please don't worry about it. We'll kind of cover all of this as we go forth. All right, so this is the workflow that exists in the Git currently, which is, this is the way you will actually be storing your files and working with it. So first is you will add a file to Git. Well, we will see this, so don't worry about it. Then what the second step of doing this is called staging a file. So there is a staging area or a concept of a staging area that exists within the Git source control, where you're actually going to keep all the files that you want to put in as a commit is kept. So this is called the staging area. The staging area is also used for the concept or in the concept of change sets for people who are familiar with it. What staging area provides you is the opportunity to check in multiple files at the same time. So let's say you've initiated a new project and, using a template, you may get, 5, 10 files simultaneously. So you don't want to manually go in and check each of them individually. And because basically this is your initial start of the project. So what you could simply do is you could say, put all the files in the staging area and then commit the change set that you have just put in. So as you commit, all the files will be put into the version control system with a single comment saying initial files or the first version of files. So that's what committing a change set means. So as you continue to work with your files, you will be committing various change sets to the version control systems, and comments are mandatory in Git. So you can't check in a change set without a comment. You will have to put in some comment of some nature. So this is how Git provides you information about the change set as you go forth. So you will be committing your source files to the source control using commit. Finally, at a certain point, you may want to roll back something that you've done and want to probably refer a previous version of whatever work that you were doing. So that is achieved by a concept called checkout in Git. So as you check out something, this is how you will revert back to previous changes. So checking out a file essentially means that you moved back and are looking at the older version of the repository. Otherwise, it would not make sense maintaining so many versions or having a version source control. So with this concept, let me take one more slide and then we'll switch to demo. And this is working with Git locally. Now, once again, to impress upon you that currently the concept of Git we are working with, and this is only a start point, we'll extend that understanding, is that Git is a system for maintaining versions of your files in the local file system. Plain and simple. There is nothing else to it. Okay. Now, so the first thing that you need to do to get working with Git is to obviously install it, which you've already done. Then you go to a folder where you want to keep your source files. Now, this is where you go and initialize your Git folder. It's called initializing a Git repository or a Git folder. That's the first step. Now, we've seen a bit of the workflow in the past where you're going to add files, stage files, commit changes, and revert changes. You can also go ahead and view history and differences. You can go ahead and clean files. There are a few ways of cleaning files, namely there is git clean, git reset, and a concept of git ignore. So this will be a great time for me to actually stop the presentation and move into the demo mode. Okay, so 1 second. All right. I'm going to also take a look at some of the questions that may have come in. Let me see if I can read some questions. Okay, how to install Git. All right, I think I've already answered that. Demo coming up. Does it lightweight control? Not sure what that question means, but I'm believing that. Okay, you have explained it in the next question. which does take any more memory or working on which does any. Oh, all right, so probably you're asking me if this version control system is heavy on memory or is heavy on a process. So both of them, the answers is no. It's very lightweight and does not consume a lot of memory as it is running. Is it free? Yes, I mentioned this is free and open source as well. Is it similar to Tortoise SVN? So I was talking about other source controls just about now. The nature of the other source controls that we have is called, or the nature of the source controls that we had, be it Tortoise SVN, be it basic subversion, be it TFS, be it VSS, be it Perforce, all of them are of the nature of a centralized version control system. You don't really work offline in those source controls, not the way that Git does it, and they're very heavy as well on the systems. Here it is. Here we have a lot of flexibility in the way that you can actually work. So think about it this way, that when you are on a plane, you do not have internet connectivity and you want to work on some of the things that you've been working on in office, or when you're on a train, do not have internet connectivity, or in a bus, Git is your friend because it will work without access to your central source control system. In addition, not only will it work, but it will also preserve all the check-ins that you do while working offline as well. So as you're working offline and you continue to add up the code base, and you can do various check-ins. When you actually go and sync it with the central source control system, this will go and integrate it with the source control system, including all the check-ins. So that's the beauty of this. All right, so I think let's move on from there. I think there's a question on commits and check-ins. We'll kind of take a look at all of that. And yeah, let's, I think, just move on. Is it source friendly? Is it user friendly? Well, you can take a look about that right now. We can take a look at that. Okay. So I mentioned that there are 2 to 3 tools that you will get when you install Git with MSys Git. So the first tool that you need to be familiar with, and this is going to be the basis of most of the work that we will do today, is going to be this shell, or this is called the Git GUI, or Git graphical user interface. The first thing that you will do probably, or let me start with a completely fresh project. So I'm going to drag my Windows Explorer in. All right, I hope you can see that now. And what I'm going to do here is I'm going to go to my local disk. Some of it is mentioned here. And I'm going to create a new folder. This is the folder where I actually want to keep my files. So, or my source file. So this is simply a folder which actually contains nothing. Now the first step that I said was going to be to actually look at or basically initialize this folder. All right, so this is what you will get to begin with. So it says create a new repository, clone an existing repository, or open an existing repository. So at this time we are going to be creating a new repository or initializing a new repository. So what we need to be choosing is create a new repository. It'll ask you the directory. So this is the new directory that we created, which was C Git demo. So I will go into this PC, C Git demo. All right. Okay, and I will say create. As I say create, notice what happens in the folder itself at the back. It has added a .git hidden folder. Now it has a lot of these things which are there, which is requires for internal working. So remember the concept that I gave you to begin with, which is treat it as a simple version control system for your files on the disk. So what you will do next, let's assume, is you're going to add a first file in this project. So you're going to call this file, what do you want to call this file? Let's say information. This is the first file that you want to add. So in information, I want to add some bit of text. I can say, well, hello Git. So that is pretty much all we add, and we close it. Now we also want another file, which is probably going to be a new document file, and I'm choosing another file because of a specific reason. It's not just text files that Git can commit. It can also commit files of other nature. So I'm going to pick up another file, which is a document file, and I'm going to call it the architecture. So this is going to be the architecture of the system that we are designing, or whatever you want to put in the architecture. So I'm going to say again, hello Git, and probably just to make sure that we add something interesting, how about we add a smart chart of the nature of picture caption list, and say, well, Git local remote. Awesome. All right, so we'll kind of, we've added some additional things in here, and I'm going to just save it. Done. All right, so the next step, so we have some files that we have just created. What we want to do next is to, as I said, if you remember the sequence of steps, it was add a file or stage the file. So we've added the files in the source control. We are going to be now staging these files. Now staging these files mean that you have to go into Git GUI and scan the current folder. So you press the rescan button right here, and what you will get is the two files that you've just added. So Git has detected that these are the two files that have been added, and they've been put in the area called the unstaged changes, if you notice here. This is the area that I'm referring to. Do you see this? Unstaged changes. Now, after you've done unstaged changes, you will want to stage this. As I mentioned, the reason that we're trying to stage this is to create those common commits. So I can press Control-I, and it is asking me stage two untracked files. So you will say, yes, I do want to stage both of them. Now, if you notice, I'm going to be committing these two files together. So I can actually leave an initial commit message, or I can write a commit message and click on commit, which is indicated in the right-hand side. So if you notice this section, that's what I've been talking about, commit. So let me commit it, and before I can commit, let's try and press this commit button, and it says please supply a commit message. So, well, you know, you do need to provide the initial commit message. So we're just going to type in initial commit, and we're going to say commit. Well, so the commit has happened, and it has gone through. Let's go back to the file and make some changes. So I'm going to write another message, says that commit was cool. Now here is where the versions start to make more sense. So, all right, second line says that commit was cool. Can you check me in too? So I've made a change in one of the files, and I want to now go ahead and check this in. It's always said that check in your code often. Now it's a good time to revisit that. So you'll go ahead, and again in the Git UI you can say rescan. So what I did was use this particular button at the bottom, which is rescan. Okay. Now as I did this rescan, Git again detected that there's a change in information.txt file. And if you notice on the right hand side, a big window at the top here, it is also showing you the contents primarily because it's a simple text file. So it is showing you the fact that they've added a new line called that commit was cool. And as you can see, it's showing you it is going to remove hello Git, add hello Git, add a new line, and this. So this is essentially the difference between the two files. I'm going to then again get this into the staging area by pressing Control I. It has gone into the staging area, and I'm going to leave another comment. So I'm going to say this is the second commit, and I'm going to say press that commit button as well. All right, so now we have two commits. Let's go and make a change to the doc file as well. So I'm going to say changing a binary file. Okay, go in, save. I'll go back out to the Git shell, which is Git UI. Press this rescan button. So I think now you're getting the flow that we are actually using. And say, say binary file changed. All right, commit. All right, what would be the use if, we've made all these changes, and how do we look at the history of whatever we have changed? So this is about now looking at the history of whatever it is. So we can go into the repository and say visualize master's history. So just go with the flow. Basically understand this is the history that we will be tracking. And to bring that in, I mentioned the tool called GitK, which is meant for visualizing these changes, and that we have here. So if you notice, all our check-ins are indicated as initial comment, second commit, which we made to the notepad file, and this is the third commit that was done on the binary file changed. Now there is another interesting piece of information in this screen, and that is this particular section, the SHA-1 ID section. So let me zoom in. So this is the SHA-1 that I was talking about. Now what is SHA-1 ID? Each time you make a commit, Git calculates the checksum of all the files put together and generates a unique SHA-1 ID. So internally, Git maintains versions based on this particular value. So it is the identifier for the particular check-in or the commit that has happened. So hope this has given you a view of what SHA-1 means. So remember, this is what we will need to make changes or revert changes, and this is one of the most important pieces of information when you think about Git and working with Git. All right, so let's move on. We've seen how to put in changes, how to actually go ahead and commit those changes and see the branch or view the hierarchy of changes that are happening at this time. So let us move on and switch back to slides so that we can come back to working with more pieces, and then we'll move further. So I'm going to then move on and show this slide. So I think this is what we have just covered. Okay, so the cleaning files with git ignore. All right, so let's do this git ignore as well for a second.
Let us now see how to go back in time or revert some changes. So it would not make sense to use a version control if you cannot go back in time and see how that work was. So what we are going to do is I've already made some additional changes in the information.txt file, and you will notice I have added this line. It is called "we will try to revert this change" in the current version, and I've already committed it to the Git source control. You will notice that the Git is currently in a clean state, and what we're going to do next is to revert this change. Now, to do that, first we will need to understand the master's history. If you notice at the top, our current head is pointing to the master branch, and the commit ID is mentioned as 4A96. The commit in which I had added this extra line was commit to be reverted. Now, where I want to go is this change where we had done the binary file changed. Now, to do that, I will just need to know the SHA-1 of this commit. Call it Control C. I'm just copying it. And back in the Git GUI, I'm going to go to the branch menu and use the checkout. In here, I'm going to copy the revision expression which we copied, or the SHA-1 ID that we copied, which is basically the commit ID, and then we're going to say checkout. So we get a message which talks about you're no longer on the local branch, which is the head is now not pointing to the latest commit on the master branch. So we're just going to say OK. If we go back to the folder, you see the file is still here. But if I open the file, that line is completely gone, the line that we had added. You can also verify the checkout by revisiting the Git K tool. You will notice that now we are at the binary file changed commit of the master branch. So this is the way you can actually retrieve the versions from a previous commit. Let us go back and revert to the latest version. I can simply say again branch checkout and go to the local branch, and simply by doing that you will notice our changes have come back.
What I'm going to do is I'm going to add a file which basically is, let's say, a fragment which you don't want to track, and I'm just going to call this a file that you don't want to use. Let's call it what? Tilde temp. Sorry. So and name the extension, yep, TMP. Now I'm pretty familiar. You've seen these files lurking on your file system. So these are the kind of files that we don't want to track. There may be files in transition. There may be logs that you don't want to track. Git ignore is the mechanism that you go ahead, that basically you use to do that. Now, the simplest way of adding a git ignore is to just create that git ignore file and check it in as well.
Let us now remove the temporary file that has been introduced in the tracked Git folder, the cgit demo. We talked about removing this using the git ignore file. So let's see how we can add that file. I'm going to start Notepad and author a new file. Alright, so in the Notepad, what we are going to be doing is mentioning that we want to ignore these kinds of files. So what I've really written here is a simple regular expression saying all the files that end with the extension TMP should be ignored from the Git repository. Now I can save this file, and we don't want to actually save it as a text file, so all we want to save it as is .git ignore with no extension. Just by saving this file, and let me do this rescan. As you can see, the TMP file has disappeared from the unstaged changes. So this is significant because the TMP file is still here in the folder. All we've added is the git ignore. So the git ignore file really can be used not only to remove particular files from the staging area, but also entire folders.
What we've till about now seen is using the Git GUI interface. Now, Git GUI interface is really something that I would say was the first step to understanding Git. Git actually originated from the Linux world. So it was written by Linus Torvalds, and obviously then they have a strong affinity to command line control or command line capabilities as well. So what actually happens is all these commands that you've seen, or all the functionality that you have seen till about now, is available in a command line as well. So I'm just trying to show you the command functions. While we'll not work too much with the command line today, because this is the first introduction, it's important to know that this is what is the default interface of Git. This is how Git actually started. The first thing I will do is, again, I will go into, let's say, the Git demo folder. This is the folder that we've been working on. That's the GUI. That's the folder where GUI is attached to as well. What I'm going to do is, the first command is obviously, I'm going to just say, let's say, just say Git. Well, Git system actually includes the Git exe in the path, so I'm able to access it from any folder. Now, these are some of the more useful commands, and Git really is a very vast subject, so we're going to only get a few things accomplished today. So here, the first thing that you would want to run is probably Git version, and as you can see, it says the version that you're currently running is 1.9.2, the msys git build. Now, another good command line to use is git help, and it will tell you how to get your Git help, and actually the lines at the bottom tell you that. Let me just type, and I'm typing at the bottom of the screen right now. I'm just going to say Git help. This is the way actually Git, basically you can add any comment, and then this will show you the Git help. There are two commands, if nothing else you remember. There are two commands that I would recommend that you remember. The first is called git log. Now, git log is the set of changes that have already happened for your repository. So in the folder or in the Git repository Git demo, this is the log that exists. So initial commit, second commit, and binary file change. We made 3 commits, and all of them are shown there. In addition, watch out for especially for the SHA-1 commit IDs that are provided with the commit function. Now, after you've done this, the other thing that you may be familiar or that you will need to acquaint yourself is Git status. Now, the Git status is an interesting piece as well. This actually is the CLI version of scanning and looking at unstaged and staged changes. So watch in the window at the back. We had one architecture.docx file and this file which was added but untracked still. So, and notice the results of what the Git status was. The first thing it said was on branch master. This means we are on a branch which is the master branch, and we'll talk about branches just about after this. Then it says changes not staged for commit. This means these are changes that have been staged, or that are that the files have changed and they have not yet been staged for commit as well. And finally, there's a third section that says untracked files. So it did detect another file, called temp, whatever, the temp.tmp, but then nothing happened. I mean, this file is something that exists on the file system, but Git is currently not tracking this file. So, all right, so the next thing that we want to look at is Git branching. Now, this is one of the most important concepts in Git. And why is it so important? I'm pretty sure people who work with other source controls are familiar with branching or branches, but why it is so important for Git is because Git branching is core to the way the Git works. So to do branching in Git, you simply say start a branch. You can actually go ahead and tag branches, and then finally you can do merging of branches. So the illustration on the right-hand side of your screen shows this workflow. So the default branch that is created for Git is called the master. So, well, you did not say master anywhere, but this is the branch that is created, and it's called the master. Now, the master, these points actually indicate various commits that may be happening. So let's say we wanted to start a branch. The simple command to do that is git branch, or you can use the Git UI interface as well. So the moment you say git master, let's create the first branch called feature branch. So this is the first commit that you will make. You will take off the master branch and create the first feature branch. Now, the moment you branch off a particular repository, which is the master branch right now, you will get a local copy of the master. Now, you're free to make changes in that branch and check the commits in. Now, similarly, as you can see, there are multiple branches that may be running in parallel. So these are other branches, feature branch 1, feature branch 2, and then they all are going to be committed to the master branch. So this is just a simple visualization on how this works. I'll kind of try and show you a better visualization. Know that there are two types of merges that you've just seen. The first one was called the first one was called the fast forward merge, and the second one is the three-way merge. Now, the difference between the two merges is the first is a fast forward merge is a simple merge, and the fast forward merge actually, the three-way merge requires a lot of work to be done. I think a better way to illustrate this will be to draw this out for you. I like to do these simple visualizations that show you how things can be done initially. So we just saw the first thing that was happening, which is this was our home, and this is the first branch that we created. So by default, this is called the master branch. Now, we've done a few commits. There were 3 commits that we've done, so 1, 2, 3. And there is a concept of a head. So head is a point in time. You can think of it as a pointer pointing to the latest commit. And actually, that's what it is. So if you look at the internals of Git, what it will be is sort of a data structure and a pointer pointing to, a pointer pointing to this data structure. The value or the details of this data structure, as I said, this is a commit data structure, and it will have the SHA-1 file system. So it's currently pointing to this. Now, as I branch off this particular commit, I'm going to get a commit or a system which is exact replica of this file. Now, I can call this branch, and then I continue working on this branch. So I'm going to make more commits, and I'm going to, let's say, call this branch as feature 1. And I'm going to continue working on this feature branch. At the same time, it may so happen that somebody else comes to the master branch and makes a few more commits. So it may start looking like this at this time. So at this point in time, what is essentially going to happen, if you notice this point in time, what is essentially going to happen is two source codes will be divergent. And now what we will need to do is a merge. So this is the merge system where a feature one is integrated back into the core source branch. Now, you can actually branch off features from any point in time from any branch, which is, so for example, if you wanted to branch off a feature 2, you can branch it off from feature 1 and continue to do commits. Or if you wanted to, let's say, you wanted to open up another experimental branch, you're trying to go to experiment 1, and you can continue to do it. If you just want to abandon the branch after some time, you can do that. You can say delete a branch. You will be able to delete this branch. Or if you want to merge the branch, you can just come about here and do the merge as well. All right. So this is how this works. And now the concept of the fast forward merge comes in. So and let's also talk about the reverts or reverting back the commits. Let's assume this is where your first head is at this time, at point in time. You wanted to see what was the version which was initially there. All you really would be doing is moving the pointer back to this snapshot which is stored in the Git repository. Now this snapshot, when you open, will contain the first file repository that you had created then. Then again, if you move forward from here to here, again, you can move the head forward, which is, and the way to move the head about is called checkout. And I think I've mentioned the word checkout when I was referring to how to revert back in time. So that's how all of this moves. Now, the fast forward merge is when the merge is going to happen on a straight branch. So when all of this, you want to commit it and you want to merge all the changes, this is where the fast forward or a simple merge will move forward. However, when you notice that the two source controls are so divergent, there are two different source codes in the master branch and the feature one. At this time, when you're actually going to do a merge, this is going to be a more complex merge because of the difference in the source codes in both of the branches. This is what is called a three-way merge. Basically, at this time, you have to manually resolve the discrepancy or conflicts that may occur between various source files. What Git provides you is three things. It provides you the local version, it provides you with the base version, and it provides you with, let's say, the remote or the future version. Now, the three versions are the base version, because this is where the divergence from the branches started. So this is the base branch. This is where you are currently at. This is the local branch, and this is the future branch. So this is the future branch. So it's going to show you in a window, just like I was showing you in GitK. That's you will see this in another tool called kdiff3. You will see three different files opened up, and it's up to you then finally to resolve what is the version and if you want to make more changes in that version. So that's how merges work. Let's actually go ahead and see what else Git can do. Till about now, we've only worked in the local file system. Now, what this means is if you wanted to collaborate, you have to expose that repository over internet. Now, the way to do that is there can be 2 to 3 things basically. And since it's about network now, there are a few Git protocols that you can look at. So Git supports these 4 protocols that I mentioned: the file, the Git protocol, the SSH protocol, and the HTTP protocol. Now, a good example, and we have a lot of, currently a lot of projects in the wild, which actually are remote Git repositories. One of the favorites is called Bitbucket. Bitbucket is a repository which is available to you, or a Git repository that's available to you for free. As you can see, I can check into all of this. I've logged in, and all the concepts that we just discussed are valid for this repository as well. But remember, this repository is not on your local system. Now, this is a remote repository. Now, I would want to obviously send some data from local repository to the remote repository. So the first thing is to link that remote repository with our local Git repository. Then we are going to do what is called a pull. So when you do a pull, basically you're pulling all the source files from the remote repository into your local repository. Then there is a concept of push. Concept of push means that all the code in your local Git repository is going to be pushed to the remote repository. I've put this small illustration, but I think drawing it is going to illustrate this in a much better way. So very simply, if you think about it, this is your local Git folder / repository. This is what we've been working on till about now. And this is the Bitbucket, or the remote Git repository. Now, in this remote Git repository, you can create the same working area. And the first thing that I said was, if this remote repository already has some, let's say, code, you would want to pull that code to yourself. So this is called pull. And if you want to send something over, which is your source files, this is called a push. Now, how does this enable collaboration? Now, this was only Abhishek, or user 1, who was working on this whole repository. Let's assume I'm joined by my friend Lohit, who's been diligently answering your questions as well. So he comes in and he wants to work on the same code that I have been working on. So he will go ahead and initiate a Git repository on his local machine. And the first thing he would say is, well, pull from this remote repository, and then he will get a localized version, a full version of the source control or the source code that is there in the core repository. Now, after that work is done, and obviously he's added his great insights into the code, improved the code, optimized the code, and then the process that he's still following is on his local remote repository is again going to be stage the changes and commit the changes. As he does this, he's kind of starting to maintain a version of the repository itself. Now, when he's ready to push this, he will just say push, and this will go to the remote repository. Now then, the remote repository becomes the single source of truth for all the team members. Now, this is how pushing and pulling on a Git repository really works. Let's actually take a look at a few more things, and then if there's more time, we can switch to doing more demos. So if you're working in an enterprise, you have a few options of working with the Git system. The first is called the central workflow. Now, the central workflow is kind of the most common one that is currently available. Now, if you're already using something like CVS or TFS or let's say VSS, a lot of people still use that. You have all the users who are actually working off the same server. So user A, B, C, and D. All of them are working with the same version or the same source control, so to say, or the same central server. In the feature branch workflow, however, what you're going to be doing is there are two options. You can actually have more than one system, which is a Git server, and different users can be working on different Git servers. This is the physical view, and then these Git servers can synchronize amongst themselves. So this is the feature branch workflow with multiple servers. The key differentiating factor is in this workflow, you will be creating a different feature. So if you remember, we had drawn the master branch. Now each time a user would start working on a particular feature, they would actually create a new branch. So this would be called a feature A branch. Similarly, another person who's starting to work from here will open up another branch, and this will be called the feature B branch, so on and so forth. In agile teams, this can actually translate to sometimes to iteration one. Each feature can actually, you can have, let's say, an iteration. So let's say this was the iteration one branch, and out of iteration one branch, you can pick up another user story A branch. And as you continue to develop, you will open up more branches, user story B, and continue working on it. So while you continue to work, basically, you're going to be only building this master branch. So your builds are not going to be broken on a daily basis, but as you are ready, let's say you've taken 2 days to commit a code or finish the code. Once you're finishing the code, you can start to commit it back to, let's say, this iteration one branch, which is continuing. So you'll close it here. This guy can go ahead and close it there, and so on and so forth. And when your iteration one closes, then you can actually go ahead and integrate it with master. Now, this is not to say that you shouldn't have a daily build. You can build it on any branches. You can build it on the master branch. You can build it on iteration one branch. You can build on the user story A branch. So on a continuous integration scenario, if you are in an agile iteration team, probably what you would want to do is build on iteration one every day, and then the master branch can be built on at any later time. So the third way of doing it is called the pull request workflow. This is sort of a new addition, and it's widely used for internet projects which are collaborative or which are collaborated from world over. In the pull request workflow, all you're doing is you're submitting a request to somebody saying, okay, I have done some significant work. Why don't you go ahead and pull from my repository? This is basically what it means conceptually, but the way people understand it in normal way is that because of the way the features have been added into the various systems, and even the remote system that I showed you, which is Bitbucket supported, is the concept of pull request. Now, basically, what people generally understand it by submitting a pull request, you're saying take my changes in, and that's exactly what I said in the beginning as well, which is pull the changes from my repository. So these are the three ways you can work on an enterprise Git workflow. We talked about, or we've thought about integrating project management with Git as well. Now, as you're working with Git, what happens is you are wanting to track or change the status of the work item that's been assigned to you, or you may also need to indicate the time that you have spent on working with a particular feature. Now, there are various project management tools out there that you can use. The one from Telerik is called Team Pulse, and it supports the following, which is you can associate a code commit with a work item, you can update status, and you can also log time. Now, to show you how this simply would work, let me bring up the Team Pulse interface very quickly. If you've not seen it before, please do not worry. It's a simple workflow. So this is basically the project management system that I've been talking about. How about I go in and let's say there was a new feature. And this new feature it's a new, basically a new feature that's been added. I'm just going to add it as a story into the Agile tool. Probably what I'm just going to call it is, and remember now we're talking about integrating the source control with the project management systems. So if you look at the story, I'm just going to say, let's say, enter email in the file. Okay. Now I'm going to say save and close. So this is the story that is added. I mean, forget what it really means. It is immaterial. So as I go ahead and add this particular story in my system, and I don't know why is it so slow right now. So as I go in and add this story, I've been given an ID of the story, which is 19. You can also see enter email in the file here. Well, basically to configure it in Team Pulse, there are a few setting changes that you have to do. And what I'm also going to do at the back is, all right, just let me go back into Git UI, close this, and connect it to another repository that I have already configured to work with Team Pulse. So while this is coming up, I'm going to fire up Git UI again. All right. We can use, this is, I've been working with another repository called C Git Work. So now I'm connected to C Git Work, and you can see this repository also put up here, right? I do have a test file called text, and I'm going to make a change here, and I'm going to say added my email ID. So while I'm using simple text files, you can actually use any kind of files. You can use files from Visual Studio, you can use HTML, CSS, binary files. I've shown you, that's why I've shown you a binary file in the form of a doc and things like those. So just feel free to use anything. I'm going to rescan. I just changed this and I said add those changes in. I'm going to stage those changes, and I'm going to say commit, and obviously it requires a commit. Now the way you're going to specify that this is a commit which is associated with a particular work item is to indicate the work item ID, and then let's say the status. And the status is, let's say, in progress. So if you remember, we had just created it. So coming back, if I move back to the Team Pulse, you'll remember that this is currently in the status not started, which is enter email in the file. Now going back to the Git UI, I will say in progress. And let's say I say time taken for doing this is about, let's say one hour, or maybe, yeah. All right, let's just say that, and let's say commit. All right, and if you wanted to add more comments, you could. All right, so the moment you've done that, Team Pulse is actually silently tracking these changes in the back, and I have just refresh this, in a few seconds you'll see that disappear from the in progress lane to move to um, the iteration which is, sorry, the lane which is in progress. So sorry about this, because we have not assigned it any iteration, I think, and it's also not assigned to anybody, so nothing is visible right now. I'm going to quickly change those two. So it is also going to take a while, so let's see if this just works. This is already done, and as you can see, it has jumped from not started to in progress. If I click that particular user story, you will see that it is currently in progress state. So it is the in progress state, and in addition, the source link is already shown. So this is the comment. It is showing you the exact comment that we entered, and it's also showing you the time in which it was committed, and it was taken from which repository. Now this is all that that was needed to be done. You can, if you wanted to quickly see what the integration looks like, all you have to do is go into settings, go into the integration tab, and go to the Git integration tab. And this is the integration that I mentioned earlier is enabled for this particular TeamPulse instance. So that's what you are seeing there as well. So we've seen how to even integrate it with TeamPulse. Finally, if you're going to look at migrating from your current source control system to Git, this is a very simplified version of how to do that, which is to look at first is to get the local or get a copy of your entire source control files into your local system, convert it into a Git folder, and then keep maintaining one-way sync from your original repository to Git repository, which is to mean that while people continue to work on the source control that they're currently using, you'll just be doing a one-way sync from whatever is happening there into the Git repository. Finally, you will go ahead and expose the Git over network. We've not actually covered this aspect today because it's, again, slightly involved, but remember the 4 protocols that we talked about, which was the file, the Git, the SSH, and the HTTP. So you can use any of the 4 and configure the Git repository to do that. And finally, then you will ask all the developers to cut out to Git and stop using the older whatever repository you had. So I know we are badly out of time right now. Sorry about that. We took longer. We try and stay within limits. So this is pretty much what we had to cover today. And I know we've probably just scratched the surface. What I'm going to do now is go ahead and take a look at some of the questions. If you do have more questions, please go ahead and enter them in the chat window as well.